Hi, so in this video we are going to proceed with the topic of asymmetric information, and to be more precise we are going to discuss why pooling equilibrium is never a true equilibrium when it comes to the games with asymmetric information. Okay, so as you remember, pooling subgame equilibrium occurs when worse informed party has no ability or does not attempt to distinguish between different types of agents, or let's say figure out the true state of the world. So for instance, if we get back to labor market example we discussed in the previous video probably, okay. Then, for instance, employer is unable to figure out whether potential employee is a high-skilled or low-skilled laborer. So as for today, we are going to discuss it based on Cournot duopoly example, and setting of the problem is as follows. So two firms produce the same good and they are to decide on the quantity to produce under the absence of communication or cooperation. So we call this kind of uncertainty, as you remember, strategic uncertainty, when two players are not aware about the strategy of the strategies introduced by other players. So the market demand for the good is described by the function QD is equal to 100 minus P, and the market is cleared. So we assume that quantity supplied by two firms is equal to the quantity demanded by the market. We know that both firms face the constant marginal cost of production, and for the first firm this cost is equal to $7. And both firms know this for certainty. I wanted to say with certainty, and yeah. So the second firm faces marginal cost of either $9 or $20. And of course, the second firm is perfectly aware about its marginal cost. However, the first firm cannot figure out the exact value of the second firm's marginal cost. So that's why the first firm assumes that both those marginal costs are associated with equal probabilities, like let's say 50-50. The second firm can choose to reveal information about its marginal cost or not to reveal. So of course, if you watched the previous video, you could probably say that such a revelation might be unreliable, but in this problem, just for the sake of simplicity, let's assume that any revelation is reliable. So the second firm cannot lie about its marginal cost if it decides to reveal information, and the first firm will believe any information obtained from the second firm. But of course, the second firm can also decide to reveal no information at all and keep silent. So in this problem, we have to calculate equilibrium level of output and corresponding level of profits, which would correspond to pooling equilibrium. We have to discuss whether it makes any sense for the second firm to reveal information about its marginal cost and when. And finally, we are to figure out whether pooling subgame equilibrium can indeed be a game equilibrium. Okay, so let's proceed to the algorithm of solution. So first we will have to start with perfect information. Let's assume that marginal cost of the second firm is equal to 9. So you probably remember the algorithm of solving Cournot duopoly game with the strategic uncertainty, because this is like an assumption of Cournot game. So first we need to figure out profit functions of the first and the second firm. So as you remember, pi1 is equal to q1 times market price, or inverse demand function. So this expression will stand for total revenue minus total cost. So average total cost times quantity. yeah, because marginal cost is constant, and when it's constant, it's also equal to average cost, average variable cost. But okay, this is just some, yeah, technical issue. Okay, accordingly, pi2 will be equal to q2 in brackets 100 minus q1 minus q2. Again, this is just market price or inverse demand function minus 9 times q2. Okay, so then we have to apply first order condition, which means that we have to calculate partial derivative of pi1 with respect to q1 and equalize it to 0. And we also calculate partial derivative of pi2 with respect to q2 and equalize it to 0. Again, I discussed it, but as you probably remember, for the first firm, the only variable under its control is q1. q2 will be treated as some exogenous constraint. So that's why we can optimize pi1 only with respect to q1. Analogously, we can only optimize pi2 with respect to q2. So after we do this, we can derive best response functions from expressions obtained after applying first order condition. And best response function literally stands for profit maximizing level of output, depending on the level of output chosen by the other player. Or to be less specific and more general, best response function stands for optimal response, like payoff maximizing strategy, depending on the strategy which was chosen by other players. So here we have best response function for the first firm, like how many units the first firm should produce, depending on quantity of output of the second firm, and analogously we have best response function for the second firm. Nash equilibrium occurs when all the players pursue their best strategy, being aware that other players do the same. And in our case, Nash equilibrium will be defined by the intercept of two best response functions. So you just need to solve this system of equations. So I did it by putting the function of q2 instead of q2 to the best response function of the first firm, and this is the result. So q1 will be approximately equal to 31.67 and q2 will be about 29.67, which makes sense because in Cournot duopoly, the party facing higher marginal cost will produce less in comparison to party facing lower marginal cost. Okay, accordingly, pi1 calculated using this formula. So basically you just have to put optimal quantity of production to the formulas of profit. So pi1 is going to be equal to 1003 and pi2 is going to be equal to 880. Okay, so I believe this is clear. So this is just some revision from Cournot duopoly. Analogously, we assume perfect information. We assume that marginal cost of the second firm is equal to 20. So basically in this case, we analyze what is going to happen if the second firm has marginal cost equal to 20 and it decides to reveal information about its marginal cost. So we design another profit function for the second firm. Analogously, there is another best response function. So please take a look, we will need it later. And by finding the values of q1 and q2 corresponding to the intercept of best response functions, we calculate equilibrium q1 and q2. So in this case, for the first firm, the quantity of output should be equal to 35.33 in order to maximize first firm's profit, and rational second firm should produce 22.35. Correspondingly, profit of the first firm will be approximately equal to 1248, and for the second firm, the approximate value of profit will be 499. Okay, so basically here we just solve two separate games under perfect information, which means the lack of external uncertainty. assuming different values of marginal cost, different possible values of marginal cost. Okay, so now we are done with the relatively easy part of this task, and let's proceed to something more complicated. So as you remember, we assumed that the first firm is unable to figure out the true marginal cost of the second firm. So that's why instead of maximizing profit, the first firm will maximize expected profit. As you remember, although the first firm is unable to tell for sure whether marginal cost of the second firm is equal to 9 or 20, the probabilities of those marginal costs are equal. So, okay, so the first firm knows that the second firm is a rational player, and as you remember, this is best response function of the second firm if marginal cost of the second firm is equal to 9. And this is best response function of the second firm if marginal cost of the second firm is equal to 20. So this is what you have here summarized. And in this case, we can depict expected profit function of the first firm in the following way. So in case marginal cost is equal to 20 and probability of this is 1 over 2, then we calculate profit corresponding to this state of the world as Q1 in brackets 100 minus Q1 minus Q2 if marginal cost of the second firm is equal to 20 minus 7 times Q1. Another possible scenario is that marginal cost of the second firm is equal to 9, and accordingly the profit will be equal to Q1 in brackets 100 minus Q1 minus quantity produced by the rational second player corresponding to marginal cost equal to 9 minus 7 times Q1. Again, 1 over 2 just stands for probability, because in general you calculate expected value as the payoff multiplied by probability assigned to this payoff. And this is exactly what we have in this equation. Okay, so then we can simplify it a bit, open the brackets and calculate and summarize and simplify. So out of this, you can get this. So expected profit function of the first firm is going to be equal to 100Q times 1 over 2 minus Q1 square times 1 over 2 minus Q1 times Q2 if marginal cost of the second firm is equal to 20 by 2 minus 7 Q1 divided by 2 plus Q1 times 100 over 2 minus Q1 square over 2 minus Q1 times Q2 corresponding to marginal cost of the second firm equal to 9 divided by 2 minus 7 Q1 divided by 2. So of course you can open the brackets and then you can take the derivative, or you can just calculate the derivative based on this expression, and this is what you are going to get after applying first order condition. So this expression stands for, how to say it, derivative of expected profit function with respect to Q1 equalized to 0. Or basically, from this you can easily derive best response function for the first firm. Okay, so now we have it, and in this case, in order to find the solution for this game, we will have to solve a system consisting of 3 equations. Okay, and actually I would like to underline it. You cannot put response function of the second firm to expected profit function of the first firm, because in this case it will mean that the first player has first player advantage. So that's why it's not fine to put this reaction function instead of Q2 of 20. Okay, so it just corresponds to the fact that under Cournot duopoly, firms make decision under strategic uncertainty, or you can say simultaneously, but this is something more informal. Okay, so you have a system of three equations. So optimal quantity 1, depending on the value of... Why is it 11? Sorry. It should be 20. I have no idea why I have 11 here. Okay, now it's fine. So, optimal quantity produced by the first firm, depending on response of the second firm, depending on marginal cost of the second firm, best response function of the second firm if MC2 is equal to 20, and best response function of the second firm if MC2 is equal to 9. So again, system of three equations because there are three states of the world. The second firm knows for sure whether its marginal cost is 9 or 20, but the first firm doesn't. Okay, so then, just some simple algebraical problem. You have to solve this system of three equations. I decided to put Q2 out of 20 and Q2 of 9 to the best response function of the first firm, but of course it's up to you. So when you solve it, then you should get something like this. So in pooling equilibrium, if the first firm does not try or cannot figure out true marginal cost of the second firm, the first firm is going to produce 33.5 units. The second firm, if marginal cost of the second firm is equal to 20, is going to produce 23.25 units. And if marginal cost of the second firm is equal to 9, then the second firm will produce 28.75 units. So again, you can put these values to profit functions and you will figure out that profit of the first firm will be equal approximately to 1,122. For the second firm, profit will be 541 if marginal cost of the second firm is equal to 20, of course. And if marginal cost of the second firm is equal to 9, then its profit will be 827. Okay, so just to summarize, we calculated equilibrium if both players know that marginal cost of the second firm is equal to 9. We calculated equilibrium when both firms know that marginal cost of the second firm is equal to 20. Then, by maximizing expected profit function of the first firm, we calculated equilibrium under external uncertainty. So what will be the level of production and the level of profit if the first firm is unable to figure out whether marginal cost of the second firm is 9 or 20. So based on this information, we have to decide whether it makes sense or it makes no sense to reveal information about the true value of marginal cost. Okay, so this is the idea. If marginal cost of, so first, again, under any game with asymmetric information, first nature decides whether marginal cost of the second firm is equal to 20 or 9. Firm 2 knows this information, the first firm does not. So the first firm can only know whether the second firm reveals or it does not reveal information about marginal cost. So if the marginal cost of the second firm is equal to 20 and the second firm decides to reveal information, then this profit will correspond to pooling, then this profit will correspond to pooling equilibrium. Give me a second. Sorry, I had to find the slide. So again, let's start from the beginning. Marginal cost of the second firm is equal to 20. And the second firm decides to reveal information. So such an outcome will correspond to outcome of the game with perfect information. And in this case, profit of the second firm will be equal to 499. However, if the second firm has high marginal cost and it decides not to reveal information, forcing the first firm to play pooling equilibrium, then profit of the second firm will be equal to 541. And as you can see, if marginal cost is high, then rational second firm will decide not to reveal information because it will give higher payoff than in the perfect information equilibrium. If marginal cost of the second firm is low, equal to $9, then if it decides to reveal such information, it will correspond to this equilibrium, game with perfect information, and then profit will be equal to 880. However, if it decides not to reveal, then we will have this outcome under pooling equilibrium, and profit will be equal to 827. And as you can see, if there is a low marginal cost for the second firm, then it makes more sense to reveal information, because such a strategy will be associated with higher profit. Okay, so now we shall discuss why pooling is not an equilibrium. So based on this figure, diagram, decision tree, whatever, game 3, we can conclude that if the second firm has marginal cost equal to 9, it should reveal information. If the second firm has marginal cost equal to 20, it should not reveal information. And now let's analyze everything from the perspective of the first firm. So if the second firm decides to reveal information, then you find it trustworthy by the assumption of this game, and you know that the firm has either high or low marginal cost. However, as we discussed based on this game 3, if the second firm does not reveal information, you can tell for sure that this firm has high marginal cost. Because firm with low marginal cost will always reveal information. That's why if there is no revelation of information about true marginal cost, it means that this marginal cost is high. So as you can see, that's why pooling is not an equilibrium, because firm with low marginal cost will never reveal information. Firm with high marginal cost will never reveal information. Firm with low marginal cost will always reveal information. And just based on this fact, you can figure out whether marginal cost of the second firm is high or low. So that's why pooling is not an equilibrium. Okay, that's it, and thank you for your attention.